is by figuring out the speeds after the collision and the momentums after the collision. I'm going to be able to make some measurements to find out the speeds and the momentums after the collision. Because I know they will be equal to the momentum before, I can figure out the speed of the yellow car before the collision. If I'm correct, and I have correctly predicted the speed of this car before the collision, then if I change the situation and have no collision, I know this speed, I should be able to predict exactly where it's going to land, put my hand and catch it. That's the scenario. So, let me tell you what you're going to measure. So, car 2 is at the bottom, car 1 is at the top. You're going to let them collide. You're going to take a vis-a-vis, and you're going to mark on the floor where they hit. Maybe do it twice. I'll have some electronic balances so that you can also get their masses. So you want to measure their mass of each car in grams. How far they go, I'll show you that. In centimeters is fine. Meters or centimeters is fine. You also need to know the distance down. The distance down will be the same for everybody. I can't remember what it is. Okay, and that we'll use that in a second. So here's what you're going to do. You choose a point on this old track to let the car go. Try to keep the track from shaking too much. And you measure where they hit. Boom and boom. Okay. Do it a couple times. Take the average. Take a meter stick and measure the distance out to that point from the end of the track. So I would mark the end of my track. It's right where that seam is. And one of them went this far, that's 0.4, or 40, and this one 62, okay, centimeters. The height is 0.76. So let me model what you're going to do.